Something's just passed through our solar system. Something massive. Something moving at 137,000 miles per hour. Something that came from another star system, possibly 3 billion years older than our Sun. And one of the world's leading astrophysics thinks it might not be a comet at all. It might be something else, something technological. 3I ATLAS was discovered in July 25, and it just made its closest approach to the Sun on October 30th. And if Einstein were alive today, the way he'd analyze this mysterious visitor would challenge everything we think we know about what's possible in the universe. Today, I'm going to show you how Einstein would approach the greatest cosmic mystery of 2025. Not just with equations, but with his revolutionary way of thinking. Because 3I ATLAS isn't just raising scientific questions, it's raising questions about reality itself. Let's think this through like Einstein would. Before Einstein would look at trajectory, he'd look at the data that doesn't fit. And with 3I ATLAS, the first thing that jumps out is, this thing is massive. From Hubble observations, astronomers estimate its nucleus is somewhere between 440 meters and 5.6 kilometers in diameter. That makes it potentially larger than both previous interstellar objects combined. And here's where Einstein would pause. He'd ask, why is the third interstellar object we've ever detected also by the farthest, largest? Avi Loeb from Harvard points out the statistic problem. The interferal mass of 3I ATLAS is over 1 million times more than Oumuamua. Einstein would recognize this immediately as a selection bias problem, but one that points to something deeper. Think about it statistically. If interstellar objects follow a normal-sized distribution with many small ones and few large ones, we should have detected hundreds or thousands of small objects before finding one this size. According to calculations, we would expect an object with a diameter above 10 kilometers to be delivered to our vicinity once per 10,000 years or longer. So either 1, we got incredibly lucky, 2, our models of interstellar objects populations are completely wrong, 3, there's something unusual about 3I ATLAS that makes it more detectable than natural objects. Einstein would immediately focus on option 3, because throughout his career, when something seemed statistically improbable, it usually meant you were asking the wrong questions. He'd say, don't assume this is a random sample. Ask, what selection mechanism could explain why we're seeing exactly this? Now let's look at what makes 3I ATLAS trajectory genuinely strange. When discovered, it was traveling at roughly 137,000 miles per hour, 61 kilometers per second. That's fast, but not unpredictable for interstellar objects. But Einstein would dig deeper into the orbital geometry. The comet's trajectory aligns closely with the ecliptic planets of Venus, Mars and Jupiter. And this is where Avi Loeb raised eyebrows. He calculated that the probability of this alignment occurring by chance is quite low. Einstein would approach this with his characteristic skepticism. He'd create a thought experiment. Imagine you throw a dart at random into our solar system. What's the probability it enters nearly aligned with the planetary plane? The solar system is three-dimensional space. The ecliptic, the plane where planets orbit, is essentially a two-dimensional slice through that space. For a randomly oriented object from interstellar space to enter along this plane is suspicious. But Einstein wouldn't jump to conclusions. He'd ask, what natural mechanism could produce this alignment? Possibility 1. Maybe the galactic disk itself has structure. Initial modeling suggests 3I ATLAS likely originated from the thick disk of the Milky Way, a population we've never detected before. Maybe objects from this population naturally have trajectories that align with planetary systems. Possibility 2. Maybe there's a selection bias we're missing. Perhaps we're more likely to detect objects that pass through the ecliptic plane because that's where most of our spacecraft and telescopes are. Possibility 3. Maybe it's not natural. Einstein wouldn't dismiss any of these without evidence, but he'd design tests to distinguish between them. Now, Einstein would do what he always did. Examine the problem from multiple reference frames, because trajectory is meaningless until you specify relativity to what? From Earth's reference frame, we see an object on a hyperbolic orbit entering our solar system at high speed, making a close pass by the Sun and then leaving forever. From the Sun's reference frames, 3I ATLAS approached from the direction of Sagittarius, which passed perihesion at 1.5 AU and will be deflected by about 18.7 degrees, departing towards the boundary between Gemini and Orion. From the galactic reference frame, here's where it gets interesting. Our entire solar system is moving through the galaxy at about 220 kilometers per second. 3I ATLAS is also orbiting the galactic center, just on a different trajectory. Its vertical velocity component, W component, is characteristic of objects from the galactic thick disk, a low metallicity region suggested high hydrogen and ice content. But Einstein would add another reference frame that most people ignore. From 3I ATLAS reference frame, from the comet's perspective, it's been traveling in essentially a straight line through curved spacetime for possibly billions of years. Then suddenly, our sun's gravity caused spacetime to curve dramatically around it. The comet followed the geodesic, the straightest possible path through curved spacetime, which to us looks like a hyperbolic trajectory. Einstein would point out, in general relativity, the comet isn't being deflected by a force. It's following the geometry of spacetime. The sun doesn't pull it on. The sun wraps the space of reality itself, comet follows that shape. This leads to a profound question. On October 21st, 2025, 3I ATLAS reached solar conjunction, hidden behind the Sun from Earth's perspective. Einstein would ask, if you wanted to perform a maneuver unobserved, when would you do it? The Hubbard effect says the most energy efficient point for a spacecraft to burn fuel is at closest approach to a massive object, when orbital velocity is greater. That's exactly when 3I ATLAS was behind the Sun, unobserved from Earth. Coincidence? Or design? Einstein would now create a thought experiment. He'd say, imagine you riding on 3I ATLAS. What do you experience? You're an object possibly 5 kilometers across, roughly the size of a small mountain. You've been traveling through interstellar space for how long? Possibly 3 billion years, longer than our solar system has existed. Think about that. When your journey began, Earth didn't exist yet. For billions of years, you experienced nothing. Complete darkness, complete silence, no acceleration, no forces, just eternal, unchanging motion. The stars don't move, nothing changes. From your perspectives, you're not moving at all. Then, over decades, one star begins to brighten. Slowly at first, then faster. You're falling towards something massive. But you feel no force. You're in free fall, following the curvature of space-time. At about 4.4 astronomical units from the Sun, something starts to happen. You develop a coma, a cloud of gas and dust. The Sun's heat is beginning to vaporize your surface, if you're made of ice. But here's where Einstein would ask the unsettling question: what if you're not made of ice? Hubble detected a dust trail, but it wasn't behind the comet as expected. It was in front of it. That's backwards. Comet tails point away from the Sun due to solar wind pressure. But 3i ATLAS just was leading it, not trailing it. Later observations showed a more normal tail, but that initial observation bothered Loeb, and it would bother Einstein too. Einstein would imagine, what if I'm not a passive ice ball? What if I'm actively maneuvering? What would I see? What would I do? And how would I hide it? Now Einstein would examine the chemistry, because what something is made of tells you where it came from. Early observations detected cometary activity starting at 4.5 astronomical units, suggesting high volatile content, lots of ice and easily vaporized materials. This supports the natural comet hypothesis. But Einstein would question the timing. He'd ask, why does activity start at precisely that distance? What determines that threshold? For a normal comet, it's about temperature. As you get closer to the Sun, surface ice reaches its sublimation temperature and begins turning directly from solid to gas. Different materials sublime at different temperatures. Water ice at one distance, carbon monoxide at another, carbon dioxide at yet another. The distance where activity starts tells you what the surface is made of. And the early activity at 4.4 astronomical units suggests high hydrogen and ice content, consistent with an object from a low metallically region of the galaxy. Einstein would see this as beautiful confirmation of cosmological models. Objects from the thick disk should have formed earlier in galactic history when heavy elements were rarer. So they should be mostly hydrogen, helium and simple ices, and that's exactly what we see. Then he'd ask the disturbing question: is this too perfect? Are we seeing what we expect to see because we expect to see it? This is classic confirmation bias, the tendency to interpret ambitious data as supporting your hypothesis. Einstein thought this his entire life. He'd demand, what observation would prove this is not a natural comet? What would we need to see? We can't discuss 3i ATLAS without addressing Avi Loeb's controversial suggestion that 3i ATLAS might be a technological object, an extraterritorial probe. Most scientists dismissed this immediately, and honestly, Einstein probably would too, at first. He was deeply skeptical of sensational claims. he'd quote his own principle. Subtle is the Lord, but malicious he is not. But Einstein would also recognize that Loeb is doing something scientifically important, considering an alternative hypothesis and proposing tests to distinguish them. Loeb points to several anomalies. The statistical improbability of detecting such a large object, the alignment with planetary planes, and the initial dust observations. Are these enough to conclude alien technology? Absolutely not. But are they enough to warrant serious investigation rather than dismissal? Einstein would say yes. Here's Einstein's methodology. Don't start with the conclusion. Start with observations. Then generate multiple hypotheses, including uncomfortable ones. Then design tests that could falsely each hypothesis. For 3i ATLAS, those tests are happening now. Recent images from November 5 show 3i ATLAS as a bright ball with a faint glow around it, but no clear cometary tail. That's odd for a comet that should be very active after perihelion. Loeb recently asked, did 3i ATLAS break up near the Sun? For a natural comet of this size, the tidal forces and thermal stress at perihelion should cause fragmentation. If it survived intact, that tells us something about the intentional structure. And here's the critical observation coming soon. On December 19th, 2025, 3i ATLAS will make its closest approach to Earth, allowing Hubble, Webb and ground telescopes to diagnose its integrity. Einstein would say, let's wait for that data, then we'll know. Einstein would recognize that we're facing an information problem. This object carries information about its origin encoded in every atom, every mineral grain, every structural feature. But how much of that information can we actually extract? From spectroscopy we can learn chemical composition, but only of the surface. We can't see inside. From trajectory we can infer its dynamical history, but only back to its last close encounter with a star. Everything before that is lost to chaos. From imagining we can see its shape and activity, but only from one perspective, and only for a few months. Einstein would see this as analogous to the black hole information paradox. Information about 3i ATLAS past exists in principle. It's encoded in the quantum state of every particle. But practically, thermodynamics has destroyed most of it. The information horizon lies somewhere in the past, beyond which we simply cannot see. This leads to a humbling conclusion. We may never know exactly where 3i ATLAS came from, how old it really is, or what happened to it during its billions of years in interstellar space. But Einstein would say, the fact that we cannot know everything doesn't mean we should not learn what we can. Finally, Einstein would step back and look at the bigger picture. What does 3i ATLAS mean? Not just scientifically, but philosophically. First, we are not alone in time. This object is potentially older than our Sun, older than Earth, older than life. It's a messenger from the ancient universe, carrying a story written in physics and chemistry. Second, the galaxy is not empty. If we detected 3 interstellar objects in just a few years, there must be countless others passing through undetected. Space between stars is filled with wanderers, refugees from dead solar systems, exiled worlds, cosmic nomads. Third, everything is connected. 3i ATLAS' specific trajectory, its velocity, its composition. All of this traces back to conditions in the early galaxy, which traces back to the Big Bang. You cannot fully understand this comet without understanding the entire history of the universe. And fourth, and this is what Einstein would find most profound, we are conscious beings, capable of understanding our cosmic context. This lump of ice and rock, or whatever it is, traveled for billions of years unconscious, unaware, just following physical laws. Then it encountered us, creatures who can measure it, analyze it, wonder about it. Einstein would see this as deeply spiritual, not in a religious sense, but in the sense of connection to something vastly larger than ourselves. He wrote, "The most beautiful experience we can have is the mysterious." 3I Atlas is that mystery, traveling through space for longer than we can imagine, passing through a small corner of the galaxy for just a moment, then continuing on into the infinite dark. So what would Einstein say about 3I Atlas? I think he'd say this: observe carefully, question assumptions, consider multiple hypotheses, design critical tests, wait for data, and don't let prejudice, either toward the conventional or the sensational, cloud your judgment. The critical moment is coming. December 19, 2025, when 3I Atlas reaches its closest point to Earth, NASA is working with congressional members to release more imagery and data. Every major telescope will be pointed at this visitor. We'll learn about its structure, its integrity after perihelion, its composition in detail. We'll see if it's fragmented as expected or remained intact. We'll search for any signs of unusual activity or behavior. And Einstein would remind us, whatever we discover, whether 3I Atlas is a natural comet, a fragment of an exoplanet, or something more exotic, it will teach us something profound about the universe. Because that's what Einstein understood better than almost everyone. The universe doesn't care what we expect. It simply is what it is. Our job is to observe honestly, think clearly, and remain humble before the evidence. 3I Atlas is out there right now, following its ancient trajectory, carrying secrets from another star system. In the coming weeks, we'll learn some of those secrets. But even if we discover it's just a comet, Einstein would say, there's no such thing as just when it comes to the universe. Every atom has a story. Every trajectory has a history. Every observation is a privilege. So if Einstein were analyzing 3I Atlas, he wouldn't tell you what it is. He'd show you how to think about what it might be. He'd teach you to question assumptions, examine from multiple perspectives, create thought experiments, test hypotheses, and remain open to surprise. That's the real lesson of 3I Atlas. Not whether it's natural or artificial, but how we approach mysteries at the age of our knowledge. The universe just delivered a gift to our doorstep, a visitor from another star, possibly older than our world. How we study it, how we think about it, how we respond to the unknown, that's the test. And Einstein would want to pass that test with curiosity, rigor, and wonder. If this video changed how you think about interstellar visitor and what they mean, subscribe to Einstein's Mind. December 19th is coming, and we'll be here to analyze whatever 3I Atlas reveals. Until then, keep watching the sky, keep questioning, keep thinking like Einstein, because somewhere out there, 3I Atlas is following its trajectory through curved spacetime, carrying questions we haven't even learned to ask yet.